In this video, our task is to learn the process of evaluating logarithmic values of some numbers with a certain base. So the first problem here is log base 7 of 49 is equal to how much? And log, there is no base here, so by default it is understood that the base is going to be 10 of 0.0001 is equal to how much? So likewise you have one more problem. So let us start off here. The first one is log base 7 of 49 is equal to how much? So let us assume that the answer is x. So log base 7 of 49 is equal to x. Now by using definition of this logarithms, we know that if log base b of a is equal to c, if you have, this logarithmic form can be transformed into exponential form as b to the power of c is equal to a, right? B to the power of c is equal to a. So using that idea or the definition of this logarithms, what happens here? This 7 to the power of x. 7 to the power of x is equal to 49. That is, we changed this expression from logarithmic form to the exponential form. So now we have 7 to the power of x is equal to 49. Okay, now our task is to find what is the value of x. That is the thing. So let us try to change this 49 in terms of 7. I have to write 49 in terms of 7, and we know that 49 is 7 times 7. 7 times 7 means 7 squared. So I can write 7 to the power of x is equal to 49. 49 change it as 7 square. Now again, using another property, those two numbers which are in exponential form and whose bases are equal, therefore the exponents must be equal here. Something like we have, like if a to the power of m is equal to a to the power of n, then what happens? M is equal to n. Because the bases are equal, the exponents will become equal. So here, because of the same 7s as the bases, the exponents became equal. So x is equal to 2. So my answer for this particular problem, that is log base 7 of 49 is equal to x, you assumed, and that x value is equal to 2. So 2 is my answer, and I can verify that 7 square means 7 times 7 is equal to 49. That's right. So 2 is the answer to this problem, right? Now what about log 0.0001? What is the value of this? Once again, I'll take it as x. Like, you know that whenever there is no base, when the base is not given for these logs, which you call it as common logarithms, in these common logarithms, the base has to be 10 by default. So whenever they didn't give the base, take it as 10. So now again, using the definition of logarithms, I will write 10 to the power of x. This 10 to the power of x is equal to 0.0001. So our question is to find the value of x. So in order to solve this problem, the best thing and the easiest way is to convert both the sides of equality with the same base. So the base on the left hand side is the 10, and on the right hand side you have a decimal form. So we have to try and convert this decimal form into a fractional, and from that fraction we should try to transform it into a number with a base of 10. So let us try. This 0.0001 can be changed into fractional form as 1 over, because of this decimal I'll write 1 here, that one came here, and 1, and afterwards 1, 2, 3, 4 digits or 4 decimal places I can say. That is 1, 2, 3, 4. So 1 over 10,000 we got. So 1 over 10,000 is same as 0.0001. So the 10,000 on rewriting in exponential form, we get, see, 10,000 is 10 multiplied 4 times, see, after 1 4 zeros, so 10 times 10 times 10 times 10, that is 10 to the power of 4. So the decimal form of 0.0001 is changed, or it is transformed into 1 over 10 to the power of 4. But again, 1 over 10 to the power of 4 is changed. You can change that as 10 to the power of negative 4 using this negative exponent property. That is, if you have a to the power of negative n, it is rewritten as 1 over a to the power of n. That property, like 1 over a to the power of n is equal to a to the power of negative n. So in the denominators, this exponent sign will be changed. So 1 over 10 to the power of 4 is changed as 10 to the power of negative 4. So we started off from where? This 0.0001 is changed into 10 to the power of negative 4. And on the left hand side, I have 10 to the power of x, and the right hand side, after all this simplification, it is transformed to 10 to the power of negative 4. So now in this equation, the base on the left hand side is 10 and the base on the right hand side is also 10. So the exponents have to be equal. Equate the exponents, that is x equal to negative 4. This x is nothing but the answer, the value of this logarithmic expression. So I will write log 0.0001 is equal to negative 4. That's my answer, right? Okay, now the third example we have here. What is the value of log base 81 of 3? This is equal to how much? Follow the same process. Let us assume log base 81 of 3 is equal to x. Then comes 81 to the power of x is equal to 3. The bases are so different, but we know that 81 can be changed, or it can be transformed with a base 3. How? 81, you know that it is 9 times 9, and 9 is again 3 times 3, and this 9 also 3 times 3. That is altogether, when 3 is multiplied 4 times, the product is 81. So 3 times 3, 9, 9 times 3, 27 times 3, 81. That is, this 81 can be transformed as 3 to the power of 4. 81 is 3 to the power of 4, and on the top I have the exponent is x. So 3 to the power of 4 whole to the power of x is equal to 3. Further, using the properties of exponents again, this rule, like if I have a to the power of, if it is a to the power of m to the power of n, the result is a to the power of mn. Power of a power, you multiply. So using this rule, 3 to the power of 4 whole to the power of x gives me 3 to the power of 4x. And on the right hand side, it is just 3. Alright, 3 by itself, so you can always write 1 as the exponent. Right? It is 3 to the power of 1. Now you have an equality with the same basis, therefore the exponents are equal. I'll write 4x is equal to 1. Solve for x, that is divide by 4 on both sides. Because of this multiplication, opposite is division. I divided on both the sides by 4, leaving behind x equal to 1/4. You got 4 and 4 cancel here, so x equal to 1/4. That is this one, log base 81 of 3 is equal to 1/4. Log with the base 81 of 3 is equal to 1/4. That's your answer, right? Okay, thank you.